Right, we have the circle homework from the Circle Higher homework from the weightmaths.weebly.com website. So we'll just run through the questions. Number one, two congruent circles. Congruent, what does that mean? That means they are the same shape and the same size. In other words, the radius of circle A will equal the radius of circle B. So two congruent circles with centers A and B touch at P, which has to be the midpoint of A and B if the length of the radius in each circle is equal. So they touch at P relative to suitable axes. Their equations are blah and blah. A, find the coordinates of AP. Well, I don't know where P is, apart from the fact it's right in the middle of A and B, it's the midpoint of A and B. So if I can find the centre of A and the centre of B, and find the midpoint, that will give me the coordinate of P. If you're thinking about the question, you find the coordinates of AP. Does that mean A and P, or does it mean A, or does it mean P? I don't actually know. I think there's something gone wrong with the question. But I'm going to find the coordinates of A and also the coordinates of P. I think it's just really asking for the coordinates of P. So circle A, there's the equation of it. There's the general equation of the circle. So if it's in this format, the centre is given by negative g negative f. So we do know that 2gx is 6x. In other words, 2g is 6 equals 6. So g is 3. 2fy has to be the same as 4y because the coefficient of y, the amount of y, has to be equal each time. So 2f equals 4, f equals 2. So the centre, remember, is negative g negative f. So the centre will be negative 3, negative 2. And we can also calculate the radius. That's g squared plus f squared minus c. We know g and f from above. C is negative 12. I should say plus c there, but it doesn't. But c is negative 12, matching them up. So we've basically got 3 squared, negative 3 squared plus negative 2 squared, subtract negative 12, which comes out as root 25, which is 5. So the radius is 5, and the centre is negative 3, negative 2. Circle B, I know the radius is 5 because it's congruent, it's the same size and shape as circle A. So just calculating G and F in a similar fashion to what I did in part A. G is negative 3, F is negative 6, so the centre is 3, 6, the radius is 5. So I'll quick look up at the question again. I'm looking for point P, which is the midpoint of A and B. Again, the reason why that is because the radius of each circle is equal to both a length of 5. So A is negative 3, negative 2, B is at 3, 6. The midpoint of the x coordinate would be right in the middle of negative 3 and 3, which is 0. The y coordinate of M would be the midpoint of the y coordinates of A and B. In the middle of negative 2 and 6 we have 2. So the midpoint of point P is 0, 2. I've also written down A again, just again not really sure what they're asking in the question there. And part B asks for the length of AB. Well, I know where A is, I know where B is. We can use the distance formula. If we forget the distance formula, just use Pythagoras. We can do a quick sketch here, see how far along we go, see how far up we go, because we've got the coordinate of each point, haven't we? So we can find out how far along, how far up, get a nice little right angle triangle, a squared at b squared equals c squared. The distance formula is basically Pythagoras, but done in one go. So it turns out to be the square root of 100, which is 10 units. Question number 2. The circle has centre negative 2, 3 and passes through 1, 6 in the equation of the circle. Now we do know that x minus a all squared plus y minus b all squared equals r squared. So we've got our a and b, it's the centre of the circle. We just need to work out r. So r is the distance from C to P. So again, distance formula. So x2 minus x1 all squared plus y2 minus y1 all squared. So the radius is the square root of 18. Centre is negative 2, negative 3. Oops, can't copy, I've got that wrong. Mistake, Mr. Young. So we'll get a pen out. This is why we should double check our work. So that will be a negative sign. Because it's x minus a all squared, y minus b all squared. And remember it equals r squared, so if r is root 18, r squared would be root 18 all squared, which is just 18. Part B, PQ is the diameter of the circle, find the equation of the tangent to the circle. Right, I can work out point Q. If I know PC, CQ will just be as far over on the other side. So a similar idea to how we normally find the midpoint. Distance for the x coordinate from P to C is a drop of 3. So C to Q will also be a drop of 3 because it's a straight line. So here we've gone from 1 to negative 2 and we'll go to negative 5 for the x coordinate. For the y coordinate we've gone from 6 to 3, so we've got to drop down another 3, so it'll be 3 down to 0. And it's sitting on the x-axis, that's reassuring. Because the y coordinate of 0 means that the point lies on the x-axis. So after we've done that, we have this point and this point. So we need to find the radius, the gradient of the radius. We can then find the gradient of the tangent because that's perpendicular to the gradient of the radius. And we've got point Q to substitute in. So radius minus 2 minus minus 5 over 3 minus 0, again using the centre and point Q. So that's 1. Gradient of the tangent is perpendicular to that, so flip it. So if you flip 1, you still get 1, and change your sign, negative 1. Substitute in our values, y minus 0 equals negative 1 bracket x minus minus 5. So multiply through, y equals negative x minus 5. And that is us. Question 3, a wee bit different to normal. For what range of values of c does the equation represent a circle? Right, for a circle, this is the important bit here. For a circle, g squared plus f squared minus c must be greater than 0. Must be greater than 0. Because that comes from the fact that the radius is given by the square root of g squared plus f squared minus c. So that value that you're square rooting there has to be greater than 0. If it was 0, you'd have a radius of 0, which is essentially a point. If it was less than 0, to find the radius, you'd be trying to square root a negative number, which is, you're not allowed to do, or you can't do. So find out what g and f are. So g is negative 3, f is 2. So here's our general equation. Here we have plus c, here we have minus c. So our value here of c is minus c rather than plus c. So substituting in minus 3 squared or 2 squared minus minus c. Again, it says plus c, but that's minus c, so we need to substitute in minus c. It's going to be greater than 0. So 9 at 4 at c is greater than 0. 9 at 4 is 13. Move it across. C is greater than a negative 13. So again, just reiterating that this must be greater than 0, because to find the radius, we'll square root this. Can't square root a negative number. We'll square root in 0, we'll get a radius of 0, which isn't a circle, it's just a point. Find g and f and c, substitute in, rearrange. Right, last question. Show this line as a tangent to the circle. To show that, we need to substitute in and show there's only one root. So we already have it in the format y equals function of x. So substitute in for y. So x squared plus y squared becomes x squared plus 4x minus 2 all squared. Substitute in here as well. Expand our brackets, tidy up. Take out a common factor. I've got 17 there, so 17 should go into these terms as well. If it doesn't, we'll have done something wrong. So we only get one root. So we've got a double factor here, so we'll only have one root, x equals 2. So we've got to make the statement, as it is a repeated root, only one point of contact, hence the line is a tangent to the circle. And I think we're asked to find the point and state the coordinates of the point of contact. So I know if x is 2, to find the y coordinate, I substitute into either equation. This one looks the most sensible to substitute into because that will give me y straight away. So y is 4x minus 2, but I know x is 2 at the point of contact. 4 2's take 2, 6, so the point of contact is 2, 6.